Hey everybody, this is Angus Pady from Fuji Graphics. I'd like to take a few minutes to explain to you and show you the benefits of using a handheld digital spectrophotometer in a production environment. So the goal of this video is to try to explain how you can use this to remove the subjectivity of making color approvals. So one of the biggest challenges in our industry is making that decision that this color is an okay color, is an approved color. And a lot of ways that I see digital print reproduction shops doing is they'll create a standard from a sample from the customer. So the customer approves that color red, and then you'll save that as maybe as a digital standard or as a physical standard, if you will. And that becomes the way in which we approve color on future print reproductions. Now the challenge with that is there's many challenges. One is lighting. You view it under different lighting conditions and that color standard can change. A different observer, a different individual will view that color differently, and that becomes problematic when we have more than one person trying to approve color because two people see color differently, and even at different angles of which you're looking at the color can reflect color a little bit differently. So we get into all this subjectivity aspects. I think it's more blue, I think it's more red, and we can really chase our tail and more importantly spend a lot of time and money trying to get that color approval. Whereas it could be already an approved color and we wouldn't have to go through all this time. The other part of it is generally there's usually one main person in most shops that gives color approval. They can't work 24 hours a day, and often you have more than one shift running. So what do you do at night, or what do you do in the morning? What do you do at lunch when that person's not available? Well, you might have to stop production. So that time down, that non-productive time is wasted time when you're not making money. So using a device like this allows you to get a fast color approval, a very accurate color approval, and it also lets you store all of your color libraries or standards in a digital form. So I'm going to show you a quick video because I'm not there to show you the device in person. This is going to give you a bit of an overview of how the device works, and something from X-Rite I think is kind of useful.
Driving innovation. Introducing the next generation in portable color measurement, Xrite's eXact. With Xrite's point-in-time handheld solutions, you can deliver exact color every time while improving your bottom line. With Xrite eXact, understanding complex industry standards is straightforward and simple, giving your production managers the best information and allowing you to save time and money. Our new touchscreen technology allows you to measure and communicate color accurately with a single click. Plus, the fresh, new, intuitive interface allows eXact to be customized to meet the needs of your specific business. You can manage your entire fleet with valuable built-in tools like IQC Basic and data capture, or maximize your investment with connections to Color IQC Print, ink formulation, Net Profiler, and eXact Manager. It's never been easier to analyze, verify, and optimize the performance of your measurement devices and finished products. And when it's time for production, Xrite eXact is the only device that holds Pantone tables and connects to Pantone Live, a secure, cloud-based spectral color database that ensures precise color at the point of production. Step up to the next generation and benefit from easy-to-use technology that gets to the right color quickly. What could be easier or more exact than that?
Okay, so that's a bit of a sales tool, but it obviously gives you an overview of the product and how it can be used in general day's use. So I'm going to show you how you can use it, as I say, in your digital print facility. So the eXact Manager is open. I'm now tethered to my eXact. So it shows me the color libraries that are on my computer and the color libraries that I could have and job templates and things on the eXact. As I say, I'm tethered by USB, and that's how you need to build your customer libraries. So let's assume that you have the swatches in front of you and you want to build a digital library of those swatches. You would come into Color Libraries. You would create a new customer. So we'll just call this Customer 1. Okay, for simplicity. And under Customer 1 now, we're going to add a new color reference. So we click plus. We're going to call this a color, and we'll call this red. Now we could enter the values. If the customer gave you an LAB value, you could just enter them in here. You could enter them in the different modes. We could go into a color library. We could pull the color from a spot color, from a Pantone. But in this case, we want to measure. So like I say, I've got the eXact connected. I've got a USB connection into my computer, and I'm simply going to just measure on the reference. Now it's the same color again, so it didn't change. But if it was a different color, I'll show you what happens. You can see how that color will update based on the color that I measure. I've done that. I did it before. So there's our red. That's part of it. Now, not only have you measured it in one way, you've captured what's called a spectral color library. So that takes into account the media, takes into account the lighting, it takes into account a lot of things. It's a much more powerful measurement method than LAB. We also can add a tolerance. Now this is where it's really, really useful. So tolerance is a pass-fail for color. And in the industry, in our industry and most industries now, we're using delta E CMC. And delta E CMC allows for that, how do I explain it? The human eye sees color a certain way. A pastel will have more visible differences than a dark brown, for example. If you have two dark browns beside each other, you could have a lot of color variation. You won't see it, versus in a lighter pastel, a small amount of variation becomes more noticeable. So CMC sort of mimics the human visual perception, or how we see color as with our eyes, instead of mathematically. So it's taken a mathematical equation, it's kind of equated it to how our eye see color. That's the best way to explain it. And delta E is a way of evaluating color differences. So from 0 to 1 is a perfect match. Very few people would say that that is a fail, or that there's any issue with the color. 0 to 1.8, 1.5 in that area is still very, very acceptable. Getting up into a 2, 2.5 is where you start to see slight variations. And that's where we usually put a fail. Because in production, if you put down a pass-fail of a 1, you're going to be throwing away a lot of material, because in our print world, our machines, our ink, our humidity, and all the variables, it causes variation. And that's acceptable in our industry. And a 2.5 to a 3.5 is really where we sort of find is the pass-fail threshold for most customers. You may have a customer that's extremely, extremely rigid, and they want a very low tolerance. But at that point, you're going to have to look at what is your costing to sell to that customer. You know, is it worth it, because they make you go through so much time, so much waste, so much effort to get that color approval? It may not be a job you make as much money at. So this is a way to sort of equate. So the average customer, we're going to say, is a 2.5 pass-fail, okay, or fail. So we're going to put 2.5 into each of these. So we've now created a tolerance for that color. Okay, so that's saved and it's in there. So now I want to drag that down, put it into my eXact. So now my eXact is, it's copied over, and I now have that red under the library customer 1. So what's also neat in this instrument is I can show you a remote control simulation of what I'm doing. So what you see here is what I see on the front of the instrument. So we're going to start off, we're going to go into basic compare, and that normally I would just touch that with my finger on the screen, but I'm going to click that with a mouse, and that takes us to our next window. Here we have a number of different ways in which we can evaluate the color. I'll start on the left and I'll move across. The first one is called best match. That's generally used in an industry where the color of the mix of the ink might be slightly different, and it's telling you that the current can only get a best match of a certain amount. Maybe not so great in ours, more in the print press industry. So let's skip that one. The next one is LCH, luminance, chroma, and hue. And we're using the delta E CMC. The difference is quite high, and the average is 44. Okay, so luminance is brightness, chroma is saturation, and hue is the color, whether it's more cyan, more purple, if you think about the color wheel. So that can be interesting in terms of trying to figure out where the color went wrong. The next one is really powerful, and that's sort of a CMY breakdown of how that color is different. So you can see that there's, between those two colors, there's a significant more magenta and yellow, and it needs the yellow to come down in order to match. So, or these guys need to come down significantly in order to match that. So we'll get into that a little bit more. And then the last one is a trend. So you can do your averaging of all that go through. So let's go back to the main one, and I'm going to measure our original sample that we used, just to give you a pass. And I'm going to make sure that we have the right sample selected, which I did not. So the next step we want to do is go into our library here, which is this button. I was in the Pantone library, so I'm going to click on the library button there, and I'm going to go to customer 1 and select that. And now I'm on customer 1 with the red, and I want to turn on this button, which is pass fail. So that will give me my pass fail tolerancing, and I'm going to exit. Okay, so now I'm back at the main window. And here you can see I have almost a perfect score. I have a 0.03 as a delta ECMC average. Device deviation is about 0.05, 0.04. So if you measure the same patch multiple times, obviously there's going to be a slight variation on that patch. If I measure it again, here we have a 0.07. You know what I mean? So there's a bit of variation, but that's acceptable for what we're doing. Now, let's say we continue in print production and we get another sample that's another job that's come out a few days later, and we want to measure that and say, okay, how close is this one to the production? It's not okay. We've now failed, and we're a 0.48 from the original, so that would be a fail. And if I want to go over, I can take a look at what happened in that color. What I'm showing on the top is what's measured, and what I'm showing on the bottom is what needs to be done numerically to correct that color. So I had a much higher increase in magenta and cyan, a little less in the yellow. And then to fix that, I need to bring the magenta down that many points. Okay, so this is the density value. It's looking at it as density. It's not a 0 to 100. It's a density value. So in order to get it to where it needs to do, this 175 needs to come down 12 points. Okay, so that's important to understand. We can measure another standard and just sort of see, as production moves along, how is this color standard faring? This one is a pass. So we're much better off, and we've got the green checkbox. So the beauty of this system is it tells you where color how to fix it a little bit. It tells you if it's a pass or a fail. And you can also do, as I showed you, a trending of the color as time goes on. So we could do a measurement. The first measurement, it wasn't in there. That one is a pass. Oh, it was so low I couldn't even see it. We did a second measurement. This one could be the fail. Yeah, there's a 4.2. Let's take another sample. I've just got a bunch of samples of this red, as we move through. That one is a 0.05. It's very, very low. Take another sample. That one's a 0.62. So you can see as we move through various different samples how a pass and a fail will be shown on screen. There we go. That's the one. I think I measured the wrong sample. So that's a 205. That's not too bad. It's a fail. It's a pass, but we're still within tolerance. Okay, so if we want to make a correction, we could make a slight change to the density. But for the most part, if you need to go into that editing software and edit that spot color a little bit, you might bring the magenta and yellow down a little bit in order to keep it within tolerance if it was failing. But that's the key, is you can get a very quick and very accurate decision about whether or not you can continue with print production. And here, as you can see, 2.05 is still passing and still very good. So if you're interested in this product, give me a call. I can do a demo with you online. We can take you through the various components of how it might be more unique to your situation. But as I say, it's a great time saver. It helps you streamline your production. It cuts back on that subjectivity, which is so difficult at times. We print multiple swatches and we're trying to determine which one's the right one. We print jobs and we wait for approval. That downtime is killing us, and this device can save a lot of time. So, as I say, it's Angus from Fuji Graphics, and I look forward to talking to you about it in the future.